I will show in this video an attempt to unify quantum physics and gravitation. We will start from the wave equation and define a new thing, the electric root force. We will introduce the electron electric root force, and then we will see the implications of it on quantum physics. Finally, we will attempt to explain gravitation in that framework. And to put money where my mouth is, here is the cash bounty. I will give $500 of my own money to the first person that explains the value of this constant c. We will see its value in the next slides. The wave equation solution in Cartesian coordinates gives the photon. I claim that it also gives the electron for spherical solutions. And here is the form of the field. If you want to know where this comes from, I detail the math in my previous video as well as beautiful 3D plots. Let's compare our electron to what electromagnetism says. Oops, there's a 1/r discrepancy. I introduce a new physical quantity that I call electric root force. It is defined such that the force between two objects is the electric root force of object 1 times the electric root force of object 2. To find the value of our constant c, let's compare it to the force between two electrons, the Coulomb force. So we have our electron electric root force, and the force is defined as the product. Taking the spatial and time average of the new force we defined, we find this value. If we compare it to the Coulomb force, they should have the same amplitude. It gives this equation. We find that our constant c must equal this value so that the two forces match. Now let's compare the case when both electrons do not have the same phase. The average force looks something like that, and it depends on the phase shift between the two electrons. If there is no phase shift, the force is positive, so repulsive, and we interpret that as two electrons. If there is a pi/2 phase shift, it means there is no interaction between the two particles, they are bosons, etc. So what happens when we take three electrons with different phases? What happens is the nature of the particle is defined by the phase point of view. But this raises more questions. What about phase values in between? If you have answers, please comment or link another video or article. I'm interested. Okay, let's go further and find the force if we have two different particles of different masses, meaning different k. The general force averaged in time looks like that, and we can find that the first term has a spatial average of 0, except when k1 equals k2. So on average, particles only interact if they have the same k, or if they are really close. Now we assume particle 1 has a negligible wave number compared to particle 2, and we place ourselves in the case where both particles are really close compared to their wave numbers. We can simplify the equation. Then using the wave number k to mass m relationship, we find a new equation. Looks close to gravitation, no? Here's the gravitation formula. If we rewrite our force using two effective masses, we find this formula. Okay, I agree, I forced my way into it. But what this means is that if particle 1 is the sun and particle 2 is the earth, this would say that the effective mass of the sun is larger than the effective mass of the earth as we know it, but actually its true mass is smaller than the earth's true mass. So we've defined the new electron electric root force. Remember, I will give $500 of my own money to the first person that explains the value of this constant c. More information in the previous video. The winner, if winner there is, will be announced on this channel. If you liked the video, like, comment, subscribe, and share it with physics friends.